Okay, let us see another example here. Find the resultant force of the following systems of forces. So we have this, we have that, and we have that. This one is that it's purely horizontal force going in this direction. So what do we have there? Remember our resultant, what we do, we saw that it's very easy to get a resultant of a single force. So we resolve all these forces into a single force, where x is the total of the x components of these forces, and also y is the total of y components of vertical components of all these three forces. So now, after I draw this here, so let us start by resolving. This is purely horizontal, so we don't have anything to do about it. So if you get start with this one, if I'm starting with this one, okay, let me start with this one, start the arrow, our force is going like that, so meaning I should come also like this, then I come and I meet this force here. So you see, I'm coming this side, then I come outside. This is from a right angle triangle. So which force? Now it's only based on the angle, so this one is going to be opposite to this angle. Whenever you have opposite, we get this force. Then we say opposite goes with the side because this is adjacent. This is hypotenuse. So if we have the opposite, we get this force. Opposite goes with the side of that angle, which is 55 degrees. Then you see this angle, this is going to be adjacent to it. This force here that is going inside. So here we shall be having still 7. Then cos adjacent goes with cos. As simple as that. So when you come to resolving this one, we start now this force, we need the force which is coming this side, and then another one which goes up there to meet it. So then that's how we resolve. Now, you see basing on this angle, this is adjacent. So this one is going to be the force. Adjacent goes with the cos. Cos now of this angle, 45 degrees. Basing on this angle, this is opposite. So this one will be now, this force will be 12. Then because it's opposite, it goes with the sine 45 degrees. After, I think we have resolved all into x and the y component. So now we get their total. So meaning I'm going to resolve first horizontally, like this. So my x will be, I first start with the forces that are not opposing. So the forces in that direction are, first we have this 3, then plus, I think the rest are opposing. Now, these ones are still they are going this way, so they are going to be opposite. So the moment we see that they are opposite to this arrow, we put a negative first. In the x, to start this one is the x component, which is, we start with this one of 7 cos 55 degrees, then plus and negative. Also we have this one of 12 cos 45 degrees. Start here our x component. When you press it on the calculator, there you will be getting 3 minus 7 cos, then minus 12 cos 45. It is going to give me 9.5003 newtons. So all these components, all these forces are having the area x component as that. Then after that, we resolve them vertically. There we shall be getting our y. So we start with those which are going in that direction. The first one we have this one, which is a 12 sine 45 degrees. Then we add this one. Now this one is opposing. It's going down, so we shall say plus, now minus. Because this one is going down, which will be now, you see, it's 7, then sine 55 degrees. Now instead this one is purely horizontal, it has no y component, that's why we just put there 0. Then when we simplify this, the answer we get is I'm getting here is 2.751. These are newtons. So meaning our FR now the resultant said it's given by x, y, which will be our x is negative 9.5003. Then our y is 2.7512. All these newtons. Now to get our resultant, now you see our x is negative, so this is how you are going to draw it. X is negative, then y is positive. So this is where we're starting from. X is negative, then y is positive. So y already is positive, like that. So our resultant is going to be this force. So there, and then there, this is going to be our Fr. So that's, we say it is resolved into one force because for it it's very easy to get its magnitude, and also it's very easy to get its direction. So let us call this direction theta. Okay. Now you see that this one I'm having here negative 9.5003 because it's going in that direction. Then a positive, this one is going to be 2.7512. So now to get my magnitude of Fr, this will be our resultant force. You get the x component squared, you square it, then plus the y component squared. So this will give us this will be 9.8906 newtons. Then the direction we get, now we say we get tan inverse of the opposite 2.7512 over, ignore the sign x, which is 9.5003. And so our theta here is going to be 2.7512 right now. 16.15 degrees. Now, basing on this, so that's how when you are describing, you give a description there. Or you start this one is going to be in a second quadrant. If you say from, now here you have to give the force from which force? Above the horizontal force. So therefore, the resultant force, is this 6 newtons above there. Now this is the force above there, above the horizontal force, above the horizontal. You indicate the force, the horizontal force. This is our horizontal force, this resultant. Even you can put it there, the negative 9.5003 newtons. As simple as that. Now, in some questions, they will give you a mass of a particle which is forcible acting, and then they tell you, hence find the acceleration. Let us see that in the next lesson. See you there. Please don't forget to subscribe to the channel.